The Cafferty Group, Technical Service Advisors, with offices located in Nebraska, Iowa, Kansas, and Colorado, presents Daikin 80% Gas Furnace Installation and Commissioning Technical Training Module TRF 33. Download the Daikin Tech Hub app for quick and easy on-the-go access to Daikin technical and service information directly at your fingertips, such as matchup and ratings, product diagnostic information, documents, support, and more. User-friendly interface available on Apple App Store or Google Play. Sign up for free at www.daikincity.com. For other tools and resources, please visit daikincomfort.com or daikinac.com. Additional resources and support that may be helpful: mobile apps, Daikin AC monitoring tool for Bluetooth D-Checker, the Daikin Data Loader for Bluetooth shared data loader with Daikin communicating products, Daikin Home, or Daikin Tech Hub. For technical support, call 855-DAIKIN-1 or 855-324-5461. Or on the internet at technicalservices@daikincomfort.com. The agenda for this training is as follows: product overview, unit placement, venting, gas valve and connections, wiring and controls, commissioning, temperature rise and adjusting blower speeds, and checking duct static. Product overview. Furnace controls. First, we have the Daikin 1 Plus Smart Thermostat. This is for communicating systems for models DR80TC or DD80TC. Then we have single and two-stage thermostats for non-communicating systems for models DR80TN, DD80TN, DR80SN, DD80SN. Features of the 80% efficient models. For the DR and DD80TCs, 80% AFUE, two-stage gas valve, stainless steel primary tubular heat exchanger, variable speed blower motor, the DR80 upflow horizontal, and the DD80 downflow horizontal. Warranties on the DR80 and DD80TCs: limited lifetime heat exchanger, 12-year unit replacement, 12-year parts. It is one ecosystem compatible. For non-communicating furnaces, the DR80 and the DD80TN, both 80% efficient, two-stage gas valve, stainless steel tubular primary heat exchanger, 9-speed ECM blower motor, DR upflow horizontal installation, DD downflow horizontal installation, the DR80 and the DD80SN, 80% efficient, single-stage gas valve, stainless steel tubular primary heat exchanger, 9-speed ECM blower motor, DR upflow horizontal installation, DD downflow horizontal installation. Non-communicating furnace limited warranties: lifetime heat exchanger, 6-year unit replacement, 12-year parts. Complete warranty details are available from your local dealer or at www.daikincomfort.com. To receive the lifetime limited heat exchanger warranty, the unit replacement limited warranty, and the 12-year parts limited warranty, online registration must be completed within 60 days of installation. Additional requirements for annual maintenance are required for the unit replacement limited warranty. R32 compatible furnaces. When installing R32 compatible furnaces with existing R410A outdoor units, the furnace R32 mode must be disabled. Refrigerant systems other than R410A or R32 may require an additional mitigation control board. Refer to the installation manual of the indoor evaporator coil to determine installation requirements for that supplier's refrigerant detection system. Daikin 80% furnace features. 9-speed tap gas furnace features. More speed taps. 9 speeds cooling. 9 speeds circulation. Heating speeds remain unchanged. More RPM range. 3-digit 7-segment LED display. Push buttons instead of dip switches. R410A and R32 compatible. A2L sensor terminal. Here are some available accessories for the single-stage furnaces. For upflow applications only, fossil fuel dual fuel kit, high-altitude natural gas kit, LP conversion kits, masonry vent kit for the 120,000 BTU model. For downflow applications, downflow subbase for 14-inch, 17.5-inch, or 21-inch wide furnaces. Fossil fuel kit, high-altitude natural gas kit, LP conversion kits. Some available accessories for the 2-stage upflow furnaces are fossil fuel kit. The HA4 and HA5 high-altitude kits are available for altitudes from 2,000 to 5,400 feet and from 5,400 feet to 7,800 feet. LP conversion kits. For downflow models, downflow subbase for 14-inch, 17.5-inch, and 21-inch wide furnaces. Fossil fuel kit, HA4 and HA5 high-altitude kits for 2,000 to 5,400 feet and from 5,400 to 7,800 feet, and LP conversion kits. Non-A2L furnace integration kit. Furnaces not compatible with R32 will require a furnace integration kit when pairing with an R32 cooling system. Follow instructions on the furnace integration kit to integrate a non-R32 compatible furnace with an R32 cooling system. Unit placement. Attention installing personnel. Do not lift the furnace using the heat exchanger. Damage to the heat exchanger could result. Furnace positioning. Only specific models can be installed in a downflow position. Even though there is a downflow version of this furnace, it is not designed for mobile home applications. Furnace locations. The furnace must be installed indoors. For example, attic space, crawl space, or garage area, providing the garage area is enclosed with an operating door. Ensure that the temperature of the return air entering the furnace is between 55 degrees Fahrenheit and 100 degrees Fahrenheit when operating. Furnace suspension. For suspension from rafters or joists, use 3/8-inch threaded rod. Use 2-inch by 2-inch by 3/8-inch angle iron. Length of rod will depend on the application and the clearance necessary. Furnace leveling. Leveling ensures proper heat exchanger and inducer draft motor performance. Level the unit lengthwise from end to end for proper flue pipe venting. Clearances. Provide clearances as required by local codes, gas supplier, and installation instructions. You need at least 24-inch front clearance for servicing and cleaning. Unit connections, electrical, flue, and gas piping, may require greater clearances than the minimum listed. See the chart below for minimum clearances in inches. Top clearance for a horizontal configuration is 1 inch. Closet installations. For upflow applications, the front of the evaporator coil and the furnace must face the same direction. Adequate combustion and/or ventilation air must be supplied to the closet. Furnace must be completely sealed to the floor or base. Combustion and/or ventilation air supply pipes must terminate 12 inches from the top of the closet and 12 inches from the floor of the closet. Do not remove solid base plate for side return. Below, see the chart for minimum clearance to combustible materials. Combustion air. Fossil fuel burning equipment requires combustion air for safe operation. Ensure that the equipment has adequate combustion air. To prevent the blower from interfering with the combustion air or draft when a central return is used, a connecting duct must be installed between the unit and the utility room wall. Contaminated combustion air will result in safety and performance-related problems. For proper combustion air instructions, refer to National Fuel Gas Code NFPA 54 ANSI Z223.1, Section 9.3 Air for Combustion and Ventilation, 9.3.2.1 Standard Method. The minimum required volume shall be 50 cubic feet per 1,000 BTU per hour. Air filter locations. Depending on the installation and/or customer preference, differing filter arrangements can be applied. Here's an example of possible locations for an upright upflow application: central return grill, or an external filter rack on the side of the furnace. Here is a possible upright downflow filter location: filter access door on the top of the furnace, or a central return grill. Air filter sizing. Here is a chart showing the upflow and the downflow models of furnaces and the minimum recommended filter size for each. Filter sizes are listed in the furnace installation manual. Filters are not shipped with the furnaces, but must be provided, sized, and installed externally by the installer. Failure to maintain clean filters can cause premature heat exchanger failure. A new home may require more frequent replacement until all construction dust and dirt is removed. Return air options. Bottom return. The bottom return air opening on upflow models utilizes a lance and cut method to remove sheet metal from the duct opening in the base pan. Warning: there are sharp edges, therefore gloves should be worn. Airflow areas will be reduced by approximately 18% if the duct flanges are not unfolded. Scribe lines outlining the duct flanges. Cut all 4 corners after removing the sheet metal. You can cut the tabs using tin snips or press them out by hand. On upflow units, guide dimples made at the factory locate the side return cutout locations. Use a straight edge to scribe lines that will connect the dimples before you cut your opening. An undersized opening can reduce airflow. Evaporator coil installed on a furnace. Rails are provided for installing a larger width coil to the next size smaller furnace width. Be sure to remove the rails when installing the coil on an identical width furnace cabinet. Below, see the pictures that show the bottom of the coil with the rails in place and the rails removed. The correct way is both the furnace and the coil face the same direction. Here's a picture of a correct installation with both facing the front. An incorrect installation would be any option other than both facing the same direction. Venting. Flue pipe. Use only specified materials outlined in the installation manual. All venting should be in accordance with the National Fuel Gas Code, ANSI Z223.1, or applicable building and/or air conditioning codes. Refer to the equipment's installation manual for detailed instructions. 80% gas furnaces are approved for Category 1 venting only. Category 1 venting is venting at a non-positive pressure. A furnace vented as Category 1 is considered a fan-assisted appliance, and the vent does not have to be gas-tight. Furnaces are not design certified to be horizontally vented through an exterior sidewall. The vertical height of the Category 1 venting system must be at least as great as the horizontal length of the venting system. Flue pipe upflow horizontal models. Upflow horizontal model furnaces are shipped with an induced draft blower discharging from the top of the furnace. Top is as viewed for an upflow installation. 4-inch single-wall pipe can be used to extend the induced draft blower outlet 1/2 inch beyond the furnace cabinet. A chimney transition bottom kit, part number 4053501S, may be used to rotate the induced draft motor 90 degrees to vent through the right side of the cabinet on DR80TC, DR80TN, and DR80SN models used in vertical and horizontal left applications. 80% furnace combustion air coupling. The combustion air louvers on the top panel and the burner access door have been eliminated, providing a similar look to the 90% furnaces. The new top panel has the flue vent opening near the center and the combustion air opening to the right. An air intake coupling and gasket would be field installed on the combustion air opening. A 90-degree elbow can be installed on the intake opening to guard against blockage. Flue pipe downflow horizontal models. Downflow units are shipped with the inducer draft motor discharging from the top of the furnace. The inducer cannot be rotated on the downflow model furnaces regardless of installation position. Masonry vent kit for the DR80SN. A field-installed masonry vent kit may be used when a single forced draft furnace is independently vented into a tile-lined masonry chimney. This kit may be used for DR80SN, DR80TN, and DR80TC models installed in an upflow position. The kit incorporates a flue high-limit safety button, which will interrupt power to the gas valve when a backdraft condition exists. Flue pipe in masonry chimneys. A masonry chimney used as a vent for gas-fired equipment must extend at least 3 feet above the highest point where it passes through the roof, 2 feet above any portion of the building within a horizontal distance of 10 feet, 5 feet above the highest connected equipment draft hood outlet or flue collar. All installations using masonry chimneys must be sized in accordance with the appropriate venting tables. Masonry chimneys used to vent Category 1 central furnaces must be either tile-lined or lined with a listed metal liner listed for venting a Category 1 appliance. Unlined masonry chimneys are prohibited and must not be used to vent this furnace. Flue pipe with chimney liners. An exterior masonry chimney that is not tile-lined must be lined with B-vent or a listed insulated flexible metal vent. If a B-vent liner is to be used, it must be supported adequately. Supports, such as fire stops or thimbles, must be used to prevent B-vent from coming into direct contact with the tile liner or chimney walls. The excess space between the B-vent and the chimney wall must be covered at the top of the chimney by a weatherproof, corrosion-resistant flashing. The B-vent must be topped with a listed vent cap. A listed uninsulated flexible metal vent liner may be used in an exterior tile-lined chimney that is sealed and capped. Insulation will need to be added to the flexible liner if it is required by the liner manufacturer's instructions, the previous liner was properly sized and insulated and suffered from condensation damage. Insulation for the flexible vent liner must be an encapsulated fiberglass sleeve recommended by the flexible vent pipe manufacturer. For sizing of flexible vent liners, see the table in the National Gas Fuel Code, NFPA 54, ANSI Z223.1, gas valve and connections. These furnaces have a 24-volt gas valve controlled by the integrated control module. They have a manual on and off control located on the gas valve. The gas piping supplying gas to the furnace must be properly sized based on the gas flow required, specific gravity of the gas, and the length of the run. This chart lists the nominal black pipe size from 1/2 inch to 1.5 inches, the pipe length from 10 feet to 100 feet, and shows the heating value of the gas in BTUs per cubic foot at the different gas pipe sizes and lengths. Gas valve and connections. The gas piping may be brought into the gas valve from the left or the right side of the cabinet. The installer must use rigid pipe long enough to reach the outside of the cabinet to seal the rubber grommet in the cabinet penetration. A semi-rigid connector to the gas piping can be used outside of the cabinet per local codes. 1/2 inch NPT pipe and fittings are required. Note: you may install a union inside the cabinet where allowed by local codes. Gas piping leak checks. Leak check before putting any unit into operation. Use an approved chlorine-free soap and water solution, electronic combustible gas leak detector, or other approved testing methods. Warning: never use a match or open flame to test for leaks. Propane LP kits. The single and two-stage gas valves are field convertible to use with propane gas. For single and two-stage furnaces, replace the regulator spring or springs with propane gas spring or springs from the appropriate propane conversion kit and replace orifices. For modulating furnaces, add a jumper to the gas valve for propane conversion and replace the orifices. LP conversion kits. Manufacturers' propane gas conversion kits are available. The 24-volt gas valve is field convertible to use with propane gas by replacing the orifice and regulator spring with a propane gas spring from the appropriate propane gas conversion kit. All gas to propane conversions must be performed by a qualified installer or service agency. Consult the furnace specification sheet for a listing of the appropriate LP kits. LP conversions, orifices. Remove the natural gas orifices using a 7/16" box end wrench. Visually inspect LP orifices for damage and drill size before installation. Install LP orifices and tighten with a box end wrench. Reinstall the gas manifold. Adjusting gas pressure on a 2-stage gas valve. Turn off electricity and gas supply. Connect calibrated manometer to the outlet manifold pressure tap or pressure boss. Turn the gas and power back on and cycle heating on high fire, 100%. Use a flat blade screwdriver to adjust the regulators. Turn the regulator screw clockwise to increase pressure, counterclockwise to decrease pressure. Single-stage furnaces will use the same gas pressure as high-fire stage on a 2-stage furnace. Manifold gas pressure. For natural gas, low stage 1.6 to 2.2 inches of water column, nominal 1.9 inches of water column. High stage 3.2 to 3.8 inches water column, nominal 3.5 inches water column. For LP, low stage 5.7 to 6.3 inches water column, nominal 6 inches of water column. High stage 9.7 to 10.3 inches water column, 10 inches of water column is nominal. Wiring and controls. Electrical connections. 115-volt AC line connections. Check the furnace data plate before installing electrical connections. Power supply to the furnace must be NEC Class 1 and must comply with all applicable local codes. Use a separate fused branch electrical circuit containing properly sized wire and a fuse or circuit breaker. An electrical disconnect must be provided at the furnace location. Metal conduit is not considered an acceptable substitute for an actual ground wire to the unit. Connect hot, neutral, and ground wires as shown in the wiring diagram located on the unit's blower door. For direct vent applications, the cabinet opening to the junction box must be sealed airtight. When making field power connections, it's important to get the polarity correct. Line voltage connections can be made through either the right side or left side panel. Wiring, grounding. Furnace must be electrically grounded in accordance with local codes, or the latest edition of the National Electric Code, NEC. Do not use gas piping or conduit as an electrical ground. A dedicated ground wire must be run from the furnace to the electrical panel. To confirm proper grounding, turn off the electrical power and perform the following check. Measure resistance between the neutral, white wire, and the unpainted surface of the furnace. Resistance should be 10 ohms or less. Wiring, polarity. L1 to ground should be approximately 120 volts AC. Neutral to ground should be a maximum of 0.3 volts AC. Electrical connections. Humidifier. The HUM terminal is energized with 115 volts AC whenever the induced draft blower is energized. This terminal can also provide 120 volts AC to a humidifier transformer for 24-volt applications. Humidifier HUM in and HUM out terminals. In addition, the control is equipped with a dedicated humidification relay through HUM in and HUM out. The relay will close during normal heating operation. The HUM in terminal must be powered by either 24 volts from the R terminal or 115 volts from the L1 terminal. The control can provide additional humidification features when wired to a communicating thermostat. 3 modes of operation can be selected within the thermostat user menu. On, humidifier is turned on with a heat demand. Off, humidifier remains off. The relay never closes. IND, or independent. The humidifier will cycle with humidification demand independent of the heat demand. The mode allows the user to select one of 4 fan speeds: 25, 50, 75, and 100%. Electronic air cleaner. On the control module, there are terminals for 120 volts AC hot and 120 volts AC neutral to provide power for an electronic air cleaner, connecting a zoning and accessory board. Accessory zoning board, humidifier and electronic air cleaner example. From the accessory zoning board, the T2 transformer common connection will run to the 24-volt AC connection on the integrated control module. The T1 alarm A2L connection will run to the A2L alarm connection on the integrated control module. The accessory number 1 T9 hot terminal will run to the EAC terminal on the integrated control module. The T5 accessory number 2 hot terminal will run to the humidifier terminal on the integrated control module. The T10 and T6 connections on the accessory zoning module will both run to the neutral terminals on the integrated control module. The electronic air cleaner would connect to the accessory board on terminals T7 and T8, hot and neutral, accessory 1. The humidifier would connect to the accessory board on terminals T3 and T4, hot and neutral, accessory number 2. In normal operation, no leaks, accessory power on, here are functions for the accessory zoning board. R32 leak detected, alarm activated, all relays on zone mitigation board button. Power to accessory is removed. Mitigation mode ends, relays button back, and accessory has power again. Here's another accessory example using a UV light. The UV light would connect to accessory 1 terminals, hot and neutral, and the UV light power would run from T9 and T10 accessories with 120 volts out to run either a 120 volt or a 24 volt transformer, field supplied, mounted outside the furnace cabinet, for power to the UV light. Low voltage wiring. Here's a look at the integrated control module for a DR80TC. The DR80TC is designed to be a communicating furnace, but it can be configured as a non-communicating furnace. Furnace integrated control module provides terminals for W1 and W2, terminals for Y1 and Y2. This allows the furnace to support 2-stage heating only, 2-stage heating with single-stage cooling, 2-stage heating, and 2-stage cooling. Blower heat off delay. Begin with the power on and the system in idle. The display will show IDL. Use the left or right buttons to scroll through the menu options until 9FD is displayed. Press the center button to select. Use the left and right buttons to scroll through the options. Heat off delay options are 30, 60, 90, 120, 150, and 180 seconds. Press the center button to confirm the selection. Factory default is 90 seconds. Thermostat heating stage selection for the DR80TN and the DD80TN. A single or 2-stage heating thermostat can be used to control this furnace. To select which type of thermostat you are using, locate the AHS menu by pressing the left or right menu buttons. Press the center button to enter the AHS menu. Use the left or right buttons to scroll through the available options. NO is a setting for a 2-stage thermostat, which is the default setting. 10, 20, 30, 60. Selected values will indicate the number of minutes the unit will run in low stage before transitioning to high stage. AUT, the timing for the transition to second stage, will be calculated by the control board based on run time of previous heating cycles. Once the desired selection is made, press the center button to enter your selection. The DR80TN and the DD80TN using a single-stage heating thermostat. In auto mode, the transition to second stage heat will vary between 1 and 12 minutes. For instance, if the duty cycle is 0 to 38%, first stage heat will operate for 12 minutes, then transition to second stage for a light demand. Between 39 and 50%, first stage heat will operate for 10 minutes, then transition to second stage, light to average demand. From 51 to 62%, first stage heat will operate for 7 minutes, then transition to second stage for an average demand. From 63 to 75%, first stage heat will operate 5 minutes, then transition to second stage. That is for average to heavy demand. From 76 to 88%, first stage heat for 3 minutes, then transition to second stage. That would be a heavy demand. For 89 to 100% duty cycle, first stage heat would come on for 1 minute, then transition to second stage, also for heavy demand. Low voltage wiring, single stage heating with single stage cooling. Here's a wiring diagram showing the connections needed between the thermostat and the furnace integrated control module. For single-stage cooling applications, a jumper wire may be required between Y1 and Y2 at the furnace control in order to get the desired single-stage cooling airflow. Use of ramping profiles and dehumidification features require a jumper between Y1 and O. Here are the wiring diagrams showing the necessary connections between the thermostat and the furnace integrated control module for a 2-stage heat, single-stage cool application and a 2-stage heat, 2-stage cool application. S5-1 Dehumidification. Begin with the power on and the system in idle. Use the left and right buttons to scroll through the menu options until DHL is displayed. Select 1 to enable dehumidification when the thermostat DH terminal is energized. Select 0 to enable dehumidification when the thermostat DH terminal is de-energized. Default setting is 1. Steps to install and connect a dehumidistat. Connect the dehumidistat neutral wire, white, to the DEHUM terminal on the integrated control module. Connect the dehumidistat hot wire, black, to the R terminal on the furnace integrated control module. Connect the dehumidistat ground wire, green, to the ground screw on the furnace junction box. Once the button is set, the dehumidify function is enabled during a combination call for cooling. Trim enabling. To enable adjustments, begin in idle. Use the left and right buttons to scroll through the menu options. Select CTF to set the cooling trim, or select GTF to set the heating trim. Select -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, or 10 trim. Press the center button to confirm the selection. R32 sensor wire routing. The R32 sensor wire, coming from the indoor refrigeration coil, will need to be routed into the furnace and connected to the connection points on the furnace integrated control module. The wire should be routed alongside the thermostat wires through the low voltage openings in the left or right side of the furnace blower compartment. Note: wire routing must not interfere with the circulation blower operation, filter removal, or routine maintenance. Wire should not be routed near hot surfaces and should be protected from sharp edges. The Daikin 1 Plus Smart Thermostat. The Daikin communicating system is one that includes a Daikin communicating gas furnace, an air conditioner or heat pump, with a Daikin 1 Plus Smart Thermostat. Indoor unit, outdoor unit, and thermostat interact and communicate digitally with one another. This would be for the models DR80TC and DD80TC. The Daikin communicating system. Digital communications. The two-way digital communication between the thermostat and subsystems is the key to unlocking the benefits and features of the Daikin communicating system. Two-way communications is established using only two wires. The digital communication data wires connect to 1 and 2. R is 24 volts AC hot. C is 24 volts AC common. Airflow considerations and operation and airflow demand table. The thermostat determines which unit calculates the system airflow demand. If the indoor unit is responsible for airflow demand, it calculates demand and sends it to the ECM motor. If the outdoor unit or thermostat are responsible for airflow demand, they calculate demand and transmit it along with a fanned request to the indoor unit. Indoor unit then sends the demand to the ECM motor. The thermostat may be configured for 4 different continuous fan speeds: 25%, 50%, 75%, or 100%. Operation and airflow demand table. Utilizing a communicating system, if the system is an air conditioner and furnace, and the mode of operation is cooling, the airflow demand source is the air conditioner. If the mode of operation is heating, the airflow demand source is the furnace. If the mode of operation is continuous fan, and there is no current call for heating or cooling, the airflow demand source is the thermostat. For communicating heat pump and furnace, if the system operation mode is cooling, the airflow demand source is the heat pump. If the system mode of operation is heat pump heating only, the airflow demand source is also the heat pump. If the system operation mode is auxiliary heating, the airflow demand source is the furnace. If the system operating mode is continuous fan and there is no call for heating or cooling, then the airflow demand source is the thermostat. If the system is a furnace and a non-communicating single-stage air conditioner, if the system operating mode is in cooling, the airflow demand source is the furnace. If the system operating mode is in heating, the airflow demand source is the furnace. If the system operating mode is in continuous fan and there is no current call for heating or cooling, the airflow demand source is the thermostat. Communicating furnace with a communicating air conditioner or heat pump. 2 wires are required between the outdoor unit, air conditioner or heat pump, and the gas furnace integrated control module. These wires are for communication only and will be connected between the outdoor unit and the gas furnace on terminals 1 and 2. 4 wires are required between the gas furnace and the cased coil integrated control modules, and the Daikin 1 Plus Smart Thermostat. R and C are for power, 1 and 2 are for communication. Daikin communicating furnace with a non-communicating single-stage air conditioner. 4 wires are required between the furnace and the thermostat. 2 wires are required between the furnace control and the single-stage air conditioner. For this system, the Y1 terminal on the integrated control module becomes an output rather than an input. Condensate safety. The DR80TC and the DD80TC furnaces have auxiliary alarm terminals located on the circuit board. Compatible with any NC, normally closed, input device by removing the jumper. Constant 24-volt AC through the contacts. Auxiliary alarm is normally closed. System will turn off the outdoor unit and display EEF. Only used in a communicating system. Break the Y wire for non-communicating units. Commissioning. R32 compliant furnace. Note: the furnace is equipped with a control board that is capable of monitoring for R32 refrigerant leaks in the indoor coil. Please verify that the R32 sensor wire is plugged into the furnace control board before startup, if applicable. If the furnace is not paired with an R32 refrigerant system, the default settings of the furnace control board will need to be changed. Please see the R32 section in the installation manual for additional information. The R32 function on the control board is on by default. The R32 function can be disabled through the furnace control by entering the A2L function-enabled menu and selecting No. If the A2L function is disabled, the furnace control will ignore all A2L functions. If the A2L function is enabled, the control will monitor the R32 sensor information. In the case of a refrigerant leak, the control board can shut off the gas heat and turn on the blower fan to dilute the R32 concentration. The A2L function-enabled menu. Start in Idle. Press the left or right button until the LED displays A2E. Press the center button and the LED will display the selected option, Yes or No. Press the left or right buttons to select one of the two options, and press the center button to confirm the option. A2L verification. The A2L function verification menu allows the installer to verify if the A2L function operates properly. This menu simulates the refrigerant leak process and is only able to be used when there are no active alarms or faults. Perform the A2L verification function for all modes of operation one by one: cooling, heating, constant fan, and idle. Set the thermostat to one of the operation modes and ensure the system is running properly in that mode. Note which mode is being tested. To enter the A2L function verification menu, press the left or right buttons until the LED displays A2U. Press the center button and the LED will display the selected option, Yes or No. Press the left or right button to select one of the two options and press the middle button to confirm the selection. Once Yes is selected, the furnace will do the following: display the A2L refrigerant leak code, EAL. Shut down the gas operation. Energize the optional ventilation and alarm outputs. Run the fan at maximum CFM airflow. It is recommended to wait for the full 5-minute test to expire and for the system to return to the operation mode it was in. Verify the system is running properly in the operation mode chosen. Repeat the test using the other HVAC modes not previously tested. It is extremely important to verify the furnace mitigation mode functions properly for all modes of operation. The control will exit the verification function if the 5-minute timeout expires, or an alarm or fault is detected, or the user turns off the A2L function verification. The furnace must have a 115-volt AC power supply properly connected and grounded. Proper polarity must be maintained for correct operation. In addition to the following startup and adjustment items, refer to the information in the Operational Checks section of the installation manual. R32 Furnace Startup. During furnace startup, the furnace control will identify the connected R32 sensor and will start monitoring the sensor communication. A green light located next to the sensor connection will indicate if there is communication between the furnace control and the R32 sensor. The LED will be on during the duration of the startup and then either blink or turn off. The blinking LED signifies that communication with the R32 sensor is present. The LED off signifies that there is no signal with the sensor. If there are no alarms or faults, the furnace will go into regular run mode after a warm-up period. The furnace control monitors the R32 sensor once per second. Startup 7-segment display system status. When looking at the control board, the 3 7-segment displays, located just above the push buttons, will be displaying the system status. System status includes current mode of operation, as shown in the example below on the left, 2 AC, air conditioner, high stage. Airflow, as shown on the example below in the center, A12, airflow 1200 CFM. GR9S, GD9S, GR9T, and GD9T models will show operating blower speed, F0 for instance. DR80TC and DD80TC models will show the actual airflow being delivered by the blower rounded up to the nearest 100 CFM, again as shown in the center example below. Active error codes, as shown in the example below on the right. E11, error code E11. Startup, push-button menu navigation. Use the left and right buttons to scroll between the menus. Use the center button to select the desired menu when the menu code is shown on the 7-segment display. Current menu options will be displayed. The display will flash while using the left and right buttons to navigate through the available menu options. Use the center button to select the displayed option. Once selected, the display will stop flashing. DR80TC and DD80TC models require the center button be pressed again to confirm the selection and return to the main menu. Control board, the PCBB F301 on the GR9S, GD9S furnaces. Single stage, PCBB F301 with 7-segment display and push buttons is the new single-stage R32 compliant board. Offers a total of 9 speeds which allows for more coil furnace rating combinations. DR80SN, DD80SN status codes. Here are the 7-segment display status codes. IDL, idle. FAN, continuous fan. 1 AC, compressor cooling, low stage. 2 AC, compressor cooling, high stage. GH, gas heat, single stage control. Note the G looks like a 9 on the display. GR9S and GD9S examples are shown. Full list can be found in the installation manual. Menu codes. Push button menu codes. For gas heat menu codes, display makes the G look like a 9. ERR, active error menu. F10, last 10 faults. CR, code release number. RFD, reset to factory default. FSD, blower speed for continuous fan, default F01. AC1, blower speed for first stage compressor, default F04. AC2, blower speed for second stage compressor, default F05. CND, cool on delay, default 7 seconds. CFD, cool off delay, default 65 seconds. GAF, blower speed for first stage gas heat, default F01. GND, gas heat on delay, default 30 seconds. GFD, gas heat off delay, default 90 seconds. GR9S, GD9S examples are shown. Find the full list in the installation manual. DR80SN, DD80SN, heat mode speed selection. To change the main blower speed in heating mode, follow these steps. Press the left or right button until the LED displays GA1 for single-stage gas heat. Press the center button and the LED will display the current speed. Use the left or right buttons to locate the desired speed. Press the center button to select the desired speed. Note: always refer to the heating flow table and choose from the available heating speeds. DR80SN, DD80SN, continuous fan mode speed selection. To change the main blower speed in circulation mode, follow these steps. Press the left or right button until the LED displays FSD. Press the center button and the LED will display the current speed. Use the left or right button to locate the desired speed. Press the center button to select the desired speed. Press the center button and the LED will display the selected speed. All 9 speeds are available for circulation mode. Cooling mode speed selection. To change the main blower speed in cooling mode, follow these steps. Press the left or right button until the LED displays AC1 for single-stage cooling or AC2 for two-stage cooling. Press the center button and the LED will display the current speed for the selected stage. Use the left or right button to locate the desired speed. Press the center button to select the desired speed. Press the center button again and the LED will display the selected speed. All 9 speeds are available for both single and two-stage cooling. The chart on the right shows F04 is default for single-stage cooling, F05 is default for two-stage cooling. DR80SN cooling airflow. On the chart below, for fan and cooling airflow, I've highlighted the external static pressure in inches of water column from 0.1 to 0.8 inches. Below that on the chart, you will see the CFM at that static pressure and the watts of power used at that static pressure. I've highlighted the F04 tap, which is the default and recommended fan speed for the furnace listed. I've done this to give a better idea of the correlation between CFM, wattage, and external static pressure. You'll notice that as the ESP increases, the CFM goes down and the watts of power used increases. For example, at the F04 fan speed, at 0.5 inches of water column static pressure, there is 719 CFM using 138 watts of power. At 0.7 inches of water column static pressure, the CFM drops down to 641 and the watts used goes up to 151. The DR80SN heating airflow. For the external static pressure, I've highlighted again 0.1 to 0.8 inches of water column. I've highlighted the default and recommended fan tap of F02, and we're going to show the correlation of CFM and temperature rise to static pressure. So at 0.3 inches of static pressure, the CFM is 652 with a temperature rise of 45 degrees. At 0.5 inches of static pressure, the CFM is down to 554. The temperature rise is up to 53 degrees. The recommended temperature range for heat is 25 to 55 degrees Fahrenheit. Control board PCBBF302 for the GR9T GD9T furnaces. Two-stage PCBBF302 with the 7-segment display is the new R32 compliant board. It offers a total of 9 speeds, which allows more coil-to-furnace rating combinations. The DR80SN, DD80SN status codes. The 7-segment display status codes. IDL, idle. FAN, continuous fan. 1 AC, cooling compressor, low stage. 2 AC, cooling compressor, high stage. GH1, gas heat, low stage. GH2, gas heat, high stage. Menu codes, GR9T, GD9T. Push button menu codes. ERR, active alarm menu. F10, last 10 faults. CR, code release number. RFD, reset to factory default. FSD, blower speed for continuous fan, default F01. AC1, blower speed for first stage compressor, default F04. AC2, blower speed for second stage compressor, default F05. CND, cooling on delay, default 7 seconds. CFD, cool off delay, default 65 seconds. GA1, blower speed for first stage of gas heat, default F01. GA2, blower speed for second stage gas heat, default F02. GND, gas heat on delay, default 30 seconds. GFD, gas heat off delay, default 90 seconds. AHS, automatic heat staging for 2-stage controls, default no. The GR9T, GD9T examples are shown. The full list can be found in the installation instructions. DR80TN, DD80TN, heating mode speed selection. To change the main blower speed in heating mode, follow these steps. Press the left or right button until the LED displays GA1 for single-stage heating or GA2 for 2-stage heating. Press the center button and the LED will display the current speed. Use the left or right buttons to locate your desired speed. Press the center button to select the desired speed. WW1, F01 is default. W2, F02 is default. Always refer to the heating airflow table to choose from the available heating speeds. DR80TN, DD80TN, continuous fan mode speed selection. To change the blower speed in circulation mode, follow these steps. Press the left or right button until the LED displays FSD. Press the center button and the LED will display the current speed. Use the left or right button to locate the desired speed. Press the center button to select the desired speed. Press the center button again and the LED will display the selected speed. F03 is the default speed. Cooling mode speed selection. To change the main blower speed in cooling mode, follow these steps. Press the left or right button until the LED displays AC1 for single-stage cooling or AC2 for two-stage cooling. Press the center button and the LED will display the current speed for the selected stage. Use the left or right button to locate the desired speed. Press the center button to select the desired speed. Press the center button again and the LED will display the selected speed. All 9 speeds are available for both single and two-stage cooling. Single-stage cooling, Y1, F01, and F04 are default. For two-stage cooling, Y2, F01, and F05 are default. Fan and cooling airflow. On the chart below, I've highlighted the top section that shows external static pressure in inches of water column from point 1 to point 8. I've also highlighted the default speed for the DR80TN, which is F04. I've done this to show the effect that external static pressure has on airflow CFM and watts of power used. This line shows that at 0.5 inches of static pressure, the CFM is 719 and the watts of power used are 138. At 0.7 inches of water column, the CFM is reduced to 641 and the watts of power used are increased to 151. In heating mode, for a call for W or W1, at the default speed at 0.2 inches of static pressure, the CFM is 697 and the temperature rise is 30 degrees Fahrenheit. At 0.5 inches of static pressure, the CFM is reduced to 554, the temperature rise is increased to 37 degrees Fahrenheit. On a call for W2 at F02 fan speed, CFM of air is 1090 with a temperature rise of 27 degrees. At 0.5 inches of static pressure, CFM is reduced to 991, temperature rise is increased to 30 degrees. Nominal temperature range is 15 to 45 degrees Fahrenheit. Control board PCBKF321 for the DR80TC and the DD80TC. Comfort Bridge Technology. The DR80TC and DD80TC furnaces utilize Comfort Bridge technology. This can be used with the Cool Cloud application. This board is Bluetooth enabled with onboard Bluetooth. DR and DD80TC status codes. 7-segment display status codes. IDL, idle. FAN, continuous fan. AC1, compressor cooling, low stage. AC2, compressor cooling, high stage. HP1, compressor heat, low stage. HP2, compressor heat, high stage. GH1, gas heat, low stage. GH2, gas heat, high stage. DF1, defrost, low stage gas heat. DF2, defrost, high stage gas heat. The DR and DD80TC with communicating heat pump example is shown. The full list is found in the installation manual. The DR and DD80TC menu codes. Push button menu codes. CAP, Cooling Airflow Profile Setting, default, Profile D, shown as 4. CBP, Heat Pump Compressor Lockout Temperature, default, 45 degrees Fahrenheit. CFS, Comfort Setting Menu, default, 5. CRG, Enable or Disable Inverter Charge Mode. CTF, Cooling Airflow Trim, default, 0%. FSD, Constant Fan Speed as percent of maximum airflow, default, 25%. GAF, Gas Heat Airflow, percentage of maximum system airflow. GFD, Gas Heat Fan Off Delay, default, 90 seconds. GND, Gas Heat Fan On Delay, default, 30 seconds. GPT, enables gas heat at 100% for pressure testing. GSD, percentage of high stage heating airflow to run during low stage, default, 70%. GTF, gas heat airflow trim, default, 0%. L6F, view the 6 most recent fault codes and clear all fault codes if desired. LRN, restart communications between the indoor and outdoor unit. ODS, select number of stages for non-communicating outdoor unit, default, none. RFD, reset furnace settings to factory defaults. TGT, reset the target time the system will attempt to satisfy the thermostat. TON, indoor airflow for non-communicating outdoor units, default, 6 tons. The DR and DD ADTC examples are shown. The full list is found in the installation manual. Airflow settings for communicating DR and DD ADTCs. The main airflow adjustment is not required. The outdoor unit will determine the appropriate amount of indoor airflow to request. Airflow trims can be made if desired. Cooling airflow profile for the indoor blower can be changed. Airflow, cooling and heating trim for the DR and DD ADTC. The cooling and heating trim menus are used to adjust the airflow from -10 to +10% in 2% increments. Simply locate the menu in the Device Settings menu, adjust using the drop-down, and select Apply Changes to accept the selection. Airflow, Cooling Profiles, DR and DD ADTC. The variable speed circulating motor offers 4 different ramping profiles. The ramping profiles can be seen on the left, profiles A, B, C, and D. Profiles may be used to enhance cooling performance and increase comfort level. Dual fuel adjustments. Gas heat operation, defrost, DFT, is displayed. This indicates the furnace operation during a defrost cycle. Heat pump compressor lockout temperature, CBP, is displayed. The furnace will act as a primary heat source below this temperature. The default temperature is 45 degrees Fahrenheit. The settings range from -15 degrees to 65 degrees Fahrenheit. Dual Fuel Comfort Settings menu. There are 6 options available in the Comfort Settings menu, which impacts both the system target runtime and dual fuel operation. Comfort Setting options 1 through 5 have set values for the system target runtime. The default settings are dependent on the comfort setting option that was selected. Comfort setting option number 1 through 5, which is default. Target time in minutes 10 to 30. Stage up percentage, 20. Stage down percentage, 20. Over target threshold, strike count, 2, 4, 6, 8, 10. Under target threshold, strike count, 10, 8, 6, 4, 2. Dual fuel, option 6. System target runtime. Option 6 enables additional menus to customize all comfort settings. Note, it is critical that these numbers be set properly. If comfort settings option 3 is desired, but a target time of 60 is preferred, select comfort settings option 6 to enable all the adjustable menus, set the target time to 60, and make sure the other menus are set to match that of comfort setting option 3. Available adjustable menus are target time, minimum value 1 minute, maximum 240 minutes, default is 30 minutes. Stage up percent, minimum is 0, maximum 100%, default 20%. Stage down percent, minimum 0%, maximum 100%, default 20%. Over target threshold, minimum 1 strike, maximum 254 strikes, default 20 strikes. Under target threshold, minimum 1 strike, maximum 254 strikes, default 20 strikes. Dual fuel setup. This only applies if a communicating heat pump is installed. Based on target run time, the control determines if the heat pump can satisfy the demand. If not, the heat pump is temporarily locked out. The secondary heat is used to meet the demand, and the heat pump is unlocked when the control sees fit. 4 adjustable items associated with dual fuel control are stage up percentage, over target threshold, stage down percentage, under target threshold. Stage up percent shows on the display as SUP, default setting 20%. This is the setting for how long beyond the target runtime the system should continue running the heat pump before changing over to furnace. For example, the target runtime is 25 minutes. The SUP is 20%. If the heat pump cannot satisfy the set point within 30 minutes, 25 minutes plus 20%, which is 30 minutes, the furnace will fire up. Over target threshold, shown as OTT, default 2, 4, 6, 8, 10, or 20 strikes. If the heat pump consecutively exceeds the setting this number of times, the heat pump is temporarily locked out and the furnace becomes the primary heat source. Stage down percentage, SDP. Default setting, 20%. This applies when the heat pump is in a temporary lockout condition. It is used to determine when to unlock and run the heat pump again. It's determined by how easily the furnace is able to satisfy the thermostat. For example, if the target runtime, TGT, is 25 minutes, the UTT, under target threshold, is 20%. If the furnace can satisfy the thermostat in less than 20 minutes, that's 25 minutes minus 20% is 20 minutes, then a strike against the gas furnace is incremented. The strike count is important when looking at the under target threshold. Under target threshold, UTT, default is 2, 4, 6, 8, 10, or 20 strikes. If the furnace satisfies demand for the selected number of strikes, then the heat pump will be used during the next cycle. The heat pump will become the primary heat source again, and the strike count against the heat pump will be reset. Charging manually. For two-stage units, power cycle the indoor unit for more than 5 minutes. Once powered back on, cycle the operation from the thermostat. Proceed with charging during the first 2 cycles for high-stage operation. For low-stage charging, cycle the system a 3rd time. The 3rd cycle will automatically move to low-stage operation. For inverter units, select CRG from the control board menu. This activates high-stage operation for 60 minutes. It may be manually disengaged, and it automatically exits after 60 minutes. Here is a startup checklist for the furnace. Please start by adding the unit model number and serial number. In the electrical section, under line voltage, measure L1 to neutral and measure neutral to ground. Fill in the information. Then measure the secondary voltage. Measure the transformer output voltage. Then record the blower amps. Under blower static pressure, using a manometer or magnehelic, read the return air static pressure. Enter here in inches of water column. Supply air static pressure. Enter here in inches of water column. Total external static pressure, ignoring the positive and the negative from the reading above, add the totals together. Under temperatures, for return air temperature, record the dry bulb and the wet bulb temperatures. Under cooling supply air temperature, record the dry bulb and the wet bulb temperature. Under heating supply air temperature, enter the dry bulb. Temperature rise. Enter the dry bulb number. You can arrive at that number by subtracting the return air dry bulb temperature from the heating supply air temperature. And delta T, or the difference between the supply and the return air temperatures, goes here. Under the gas pressure section, please record the gas inlet pressure in inches of water column, the gas manifold pressure during low fire operation in inches of water column, gas manifold pressure during high fire operation in inches of water column. Then record the gas type, natural gas or LP. Under additional checks, check wire routing for any rubbing. Check for kinked pressure switch tubing. Check flue elbow for alignment and clamp tightness. Check the screw tightness on the blower wheel. Check factory wiring and wire connections. Check the product for proper clearances as noted by the installation instructions. As a convenience, at the bottom of the page, we have supplied the Fahrenheit to Celsius conversion formula and the Celsius to Fahrenheit conversion formula. Temperature rise and adjusting the blower speeds. Temperature rise. Temperature rise must be within the range specified on the unit rating plate. An incorrect temperature rise may result in condensating or overheating of the heat exchanger. An airflow and temperature rise table is provided in the specification sheet applicable to your model. Determine the temperature rise from the furnace data plate and conduct the following steps to adjust. Temperature rise is a great way to determine the health of a furnace and the duct system. Operate the furnace with the burners firing on high for approximately 10 minutes. Place thermometers in the return air and the supply air ducts as close to the furnace as possible. Thermometers must not be influenced by radiant heat from the heat exchanger. The cross-hatched area in the picture indicates areas that are influenced by radiant heat. Subtract the return air temperature from the supply air temperature to determine a temperature rise. The temperature rise should be within the rating on the unit's data plate. Temperature rise and adjusting blower speeds. The installation manual provides an airflow table showing the relationship between airflow in CFM, watts, and external static pressure for the proper selection of heating and cooling speeds. Adjust the blower speed to match your installation requirements and provide the correct heating temperature rise and cooling CFM. Decreasing the blower speed will increase temperature rise. Increasing the blower speed will decrease temperature rise. See the heating airflow correlation on the chart below, showing the effect that external static pressure has on the CFM and the temperature rise at the default fan speed. Heating temperature rise range should be 25 to 55 degrees Fahrenheit. Checking duct static. Refer to your furnace rating plate for the maximum ESP, external duct static rating. Too much external static pressure will result in insufficient airflow and can cause excessive temperature rise. This can cause limit switch tripping and heat exchanger failure. Reading static pressure. The positive static reading is taken at the furnace supply outlet and must be read between the furnace and the cooling coil. The negative static pressure reading is taken at the furnace return duct inlet and must be read between the furnace and the air filter. Take the duct static readings through test holes in the duct and tape up the holes once your test is complete. Steps to determine total external static pressure. Inspect or replace the filter in the furnace. Install a manometer or magnehelic into the return air duct of the furnace closest to the blower, but downstream of the filter. Measure the negative static pressure of the return duct at the inlet of the furnace. Measure the positive static pressure of the supply duct at the outlet of the furnace. When checking duct static, measure the positive static pressure of the supply duct at the outlet of the furnace. Measure the negative static pressure of the return duct at the inlet of the furnace. Your total static pressure example would be with a negative static pressure of minus 0.4 inches water column and a positive static pressure of 0.2 inches of water column. The total external static pressure would be 0.6 inches of water column. The difference between the two numbers is the total external static pressure of the system. Disregard the negative in front of the negative static pressure and just add the two numbers together. Thank you for joining us for the Daikin 80% Gas Furnace Installation and Commissioning Technical Training Module, TRF 33. If you have any questions or need more information, please contact the Cafferty Group Technical Service Advisors at one of our 12 locations.